Students, today we see the solution of quadratic equations, the completing square method. In this method, first we see the factorization method. In some problem we cannot get the factors, and hence we have to need the another method for solving the simultaneously solving the quadratic equations. For example, we take one example. Suppose x square plus 2x minus 5 is equal to 0. We have to solve this quadratic equation. Now, by factorization method, we have to find the factor of 5 such that their difference is 2. Now, the factor of 5 are only 1, that is 1 into 5. And if we have to take the difference between 5 and 1, which is 4, which is not 2, that means we cannot find the factor of 5 such that their difference is 2. And hence, in this situation, we cannot find the factors and we cannot get the solution of these quadratic equations. For this, we have to get the another method, that is called the completing square method or formula method. Now, let us see the completing square method. First, we take the first two terms, x square and 2x. Let us add a suitable term to x square plus 2x, so that new expressions would be a complete square. A complete square. That means we have to add 2x square plus 2x, the third term, which that is the complete square. Now, that means x square plus 2x plus k, we have add that k, that get the complete square, that means x plus a bracket square. Listen this step, we have to add some term, that is suitable term, which is k, that becomes this is the perfect square of x plus a. Now, here x square plus 2x plus k is equal to the square of this, we get x square plus 2ax plus a square. The expansion formula, we know that x plus y bracket square is equal to x square plus 2xy plus y square. That expansion formula we have to use here. The square of the first term plus 2 into the product of these two terms, 2ax plus the square of the second term, that means a square. Now, by comparing this, we get 2ax is equal to 2. The coefficient of x is 2 and here the coefficient of x is 2a. That means 2a is equal to 2. Therefore, a is equal to 2 upon 2, that is 1, and k is equal to a square. Therefore a is equal to 1, that means 1 bracket square, hence k is equal to 1. A is equal to 1 and k is equal to 1. We get two values at here by comparing. Next step, now we take this equation. Suppose this is first equation. Now we take the equation x square plus 2x minus 5 is equal to 0, the given equation. We substitute k at here, we get x square plus 2x plus 1. We have to add 1 k and subtract k minus 1. That means we have to add 1 and minus 1. That gets 0. Minus 5 is equal to 0. This is the important step. We have to add k and subtract k in that equation. Therefore we get, this is the perfect square of x plus the square root of third term, that is square root of 1 is 1, and the sign between these two is the sign of the middle term, bracket square, minus 1 minus 5 is equal to 6 is equal to 0. Now take 6 to the another side, we get x plus 1 bracket square is equal to 6. Now taking the square root of both sides, we get x plus 1 is equal to plus or minus root 6 by taking the square root of both sides. And hence we take 1 to the another side, we get x is equal to, if 1 is the plus, get the minus to the another side, minus 1 plus minus root 6, and hence our roots are minus 1 plus root 6 that means x is equal to minus 1 plus root 6 or x is equal to minus 1 minus root 6, and this is our solution. And the solution is x is equal to minus 1 plus root 6 or x is equal to minus 1 minus root 6. That is our final answer. We have to get 3 steps here. First we have to find a, the value of a and k, and then we have to find substitute this value at here. This is also one important step. Now we see the another example. 5x square is equal to 4x plus 7. We have to solve this by completing square method. First we write this quadratic equation in the standard form. That means take 4x and 7 to the another side. Hence we get 5x square minus 4x minus 7 is equal to 0. That is in the form of standard equation, general form. First here we get the coefficient of x square is 5, but we want this its coefficient is 1. For this we have to divide this whole equation by 5. That means we cancel that 5. Hence the next step is divide the whole equation by 5. That means 5x square upon 5 minus 4x upon 5 minus 7 upon 5 is equal to 0 upon 5. That's get 0. Dividing the equation by 5. 5 get cancelled, hence our equation become x square minus 4 upon 5x minus 7 upon 5 is equal to 0. That is our quadratic equation. This is 1, this is 2. Now the next step, that is we have to find k. For this, then let x square plus minus 4 upon 5x plus k is equal to, we have to first take these two terms, plus k is equal to x plus a bracket square. That means we have to solve this bracket x square minus 4 upon 5x plus k is equal to x square plus 2ax plus a square. Now we have to comparing these two terms, the coefficient of x and k, third term. We get 2a is equal to minus 4 upon 5. Take to the another side. Hence, a is equal to minus 4 upon 5 into 2. Hence, a is equal to minus 2 upon 5. K is equal to a square. That means minus 2 upon 5 bracket square, which is 4 upon 25. K is equal to 4 upon 25. Now the third step, that is we have to add this k and subtract the k in that equations. Now in this equation, x square minus 4 upon 5x, we have to add k here and subtract k. That means plus 4 upon 25 minus 4 upon 25 plus minus the remaining term, that is 7 upon 5 is equal to 0. So we have to write the first that equation, x square minus 4 upon 5x minus 7 upon 5 is equal to 0. Now we have to add here k and subtract k. We get x square minus 4 upon 5x plus 4 upon 25 minus 4 upon 25 minus 7 upon 5 is equal to 0. Now the first three terms is the perfect square, hence that is the square of the first term is x. The sign between these two terms, the sign of the middle term, that is negative, and the square root of this is 2 upon 5 bracket square. I repeat here, this is the perfect square of the square root of first term, that is x. The sign between these two terms is minus, which is the sign of the second term, and the square root of third term is 2 upon 5 bracket square is equal to, take these two terms to the another side, is equal to 4 upon 25 plus 7 upon 5. Now we add this. We have to get the LCM is 25, that means we have to multiply here this fraction by 5. We get x minus 2 upon 5 bracket square is equal to 4 upon 25 plus 35 upon 7 into 5, 35 upon 5 into 5, 25. The denominator is same, hence 4 plus 35 is upon 25 is equal to x minus 2 upon 5 bracket square. Now we get x minus 2 upon 5 bracket square is equal to 39 upon 25. Taking the square root of both sides, we get x minus 2 upon 5 is equal to plus minus root of 39 is root 39 and the square root of 25 is 5. Because of the square of the plus and minus is the positive. Hence the square root is positive and negative both are. Now we take minus 2 upon 5 to the another side, hence we get x is equal to 2 upon 5 plus minus root 39 upon 5. Here the 5 is the same, hence x is equal to 2 plus minus root 39 upon 5. That is our roots, hence x is equal to 2 plus 39 upon 5 or x is equal to 2 minus 39 upon 5. That is our final answer. Now students, we see the another type to solve this complete square method, which is easiest than that first method. Here the first step, we have to take the third term to the another side, that is 3y square plus 7y is equal to minus 1. That is the first step. Next, we have to get the coefficient of y square is 1. That means we have to divide the equation by 3. Therefore 3y square upon 3 plus 7y upon 3 is equal to minus 1 upon 3. Dividing equation by 3. Hence we get y square plus 7 upon 3y is equal to minus 1 upon 3. This is equation number 1 and this is equation number 2. Now we have to add here third term such that this is get the perfect square. For third term there is a formula. Third term is equal to half into coefficient of the middle term, that is y bracket square. If there is x, the coefficient of x. Here the coefficient variable is y, therefore half into coefficient of y bracket square. Hence we get the third term is equal to half into coefficient of y is 7 upon 3 bracket square. That means 7 upon 6 bracket square, which is equal to 49 upon 36. This is the second step. Then third step is we have to add this third term to the both side. Add 49 upon 36 to the both side of equation 2. How to add these to the both side of these equations. Hence we get y square plus 7 upon 3y plus 49 upon 36 is equal to minus 1 upon 3 plus 49 upon 36. Okay, and hence this is the perfect square of y, the square root of first term, plus the sign of the middle term, and the square root of third term, that is 7 upon 6 bracket square, is equal to to add this. For this we have to multiply, for LCM we have to multiply the first fraction by 12, hence is equal to minus 12 upon 36 plus 49 upon 36. Hence we get y plus 7 upon 6 bracket square is equal to 49 minus 12 upon 36, which is equal to 37 upon 36. Now we get y plus 7 upon 6 bracket square is equal to 37 upon 36 by taking the square root of both sides. Taking square root, we get y plus 7 upon 6 is equal to plus minus root 37 upon the square root of 36 is 6. Now we take 7 upon 6 to the another side, we get y is equal to minus 7 upon 6 plus minus root 37 upon 6. Here the denominator is same, therefore we get y is equal to minus 7 plus minus root 37 upon 6, and hence our final answer y is equal to minus 7 plus root 37 upon 6, or y is equal to minus 7 minus root 37 upon 6. This is our final answer. Listen student, I repeat the steps. First step, we have to take the third term to the left hand side, right hand side. Then we get the two terms, first two terms. We have to find the third terms. That is, the formula of third term is half into coefficient of y bracket square. We get that third term. We have to add this third term in the equation to the both side of the equations, and hence the left hand side is the perfect square, which is the square, and then we have to solve that example. We get the final answer. This is the easiest method than first one. We can solve this completing square method by any of these two methods. Thank you.